So I only gave you three problems, and the three problems are related to what we did in class. And actually, so this is the homework review. And we're reviewing sections 4.6, 4.7, and 4.8. For the most part, this problem relates to section 4.6. It has to do with graphing a function, a rational function. So here it is, f of x equals 1 over x minus 4 minus 3. And you are asked in this problem to find the horizontal asymptote, the vertical asymptote, the domain, the range, and a sketch. Okay, so here we go. The vertical asymptote will be x equals the opposite of -4. You know, it's always the opposite of this sign here. So x equals 4 is the vertical asymptote. The horizontal asymptote, which is the value of y, will be y equals -3. And then at this point, I begin the sketch. I don't create the domain or the range until I have the sketch, because I think that helps to understand the concept of domain and range. But this is the x-axis, this is the y-axis. Keep in mind that the x-axis is the value of y when y is 0. The y-axis is the value of x equals 0. This is -infinity and infinity and infinity and -infinity. Now we're ready to graph this thing. So we know what the parent function looks like. Oh, I think the question actually says create the. Does it say that? Does it say do the parent function?
No, it says sketch the graph of the
All right.
function.
Well, I think it's helpful to do a parent function. So let's do that. All right. So that's what the parent function looks like. And just keep in mind that when there's a negative number, when there's a negative sign in front of the fraction, then the parent function looks like this. Okay, so this is when there's a negative. Actually, we should say when a is less than 0, you know, because the general formula for this is f of x equals a over x minus h plus k. So when a is less than 0, then it's in these two quadrants. And when a is greater than 0, greater than or equal to 0, well, it's not going to be equal to 0. So let's say greater than 0, then it's in these two quadrants. So in this situation, it's positive. A is greater than 0, and therefore we're talking about these two quadrants. So x is equal to 4. Here's 4. Just a sketch, so it doesn't have to be a masterpiece. It just needs to be something that makes sense. Y is -3, let's say, is down here. That's the first step. Does anybody have a question? Okay, now you can create the graph. Knowing that it's positive here, that the vertical asymptote is x equals 4, that the horizontal asymptote is y equals -3, that's all you need to know to do a sketch. And the sketch will look like this, as you know. There's no room, so I can't go too far over there. But here, it will look like that. Again, it's just a sketch, so if this is what you have, this is what I want. Okay? Now the domain will go from -infinity to the vertical asymptote. And then from the vertical asymptote to infinity. okay? And the range, so the domain goes left to right. And the range goes up, up, and down, top to bottom. So the range will go from negative infinity, and when it reaches y equals -3, that's where it stops, and it picks up again on the other side of that, which is -3, and then goes up to infinity. But anyway, that's the problem. And of course, if you have any questions, I'm delighted, more than delighted, to answer your questions. Nobody's saying anything, so and now the next problem is from section 4.7. All right, so it's the same type of situation, except a little more complicated. And you want to do exactly the same things that you had to do up here, except there's one additional requirement, and that is that they also want to know they want you to determine if there are any discontinuities. And in parentheses, determine if there are any discontinuities, and in parentheses, it says holes. Holes, well, and this is also a very good problem, and this is the way you do it. Let me go over here to do it. Let me first call this y, and let me put that x minus 5. And in the denominator, you want to factor this. So this is x minus 5. You know immediately that if the numerator is x minus 5, the denominator is going to have an x minus 5 as well. That has to be. And then x plus 3. So this is what it looks like. And the next step would be to cancel out that, and y is equal to 1 over x plus 3. And that's a very nice problem. Some of you might be saying, well, I can understand that the vertical asymptote is going to be x equals -3. Remember, it's the opposite of +3, right? So you just keep that in mind. X is -3. But the horizontal asymptote, well, it doesn't have one. Yes, it doesn't, because it's really +0. So the vertical, the horizontal asymptote is y equals 0. Yeah, that's all that means. Yeah, it's a good horizontal asymptote because it's the x-axis. All right, and of course this is when I graph it. At this point, I would graph it, and the vertical asymptote is -3. X equals -3. The horizontal asymptote is simply going to be the x-axis. So here it is right here. X equals, y equals 0. And the graph is going to be drawn just like this. That's it. And, it's like we're saying that the original x and y axes have been moved, and now this is the new x and y axis. So again, this is the way it's going to look. And the only thing that you need to be concerned with is that since we cancel out the x minus 5, since we cancel that out, it still has to be taken into account that if x is equal to 5, that's an undefined fraction, because you cannot have a 0 in the denominator. And when x is equal to 5, 5 minus 5 is equal to 0. Therefore, there will be a hole in the graph right about over there. And all you need to do is that. I always sort of make it look like there's an actual hole, but that's not necessary. Okay? You could do it that way. And this is the point where x is equal to 5. And to figure out the value of y, you simply let x equal 5 over here. So 5 plus 3 is equal to 8, and the value of y is 1/8. And that's the whole. And you can indicate that if you'd like, or if you just simply do what I did here, I don't think you need to say it's a hole. It's pretty obvious that it's a hole in the graph, and this is where it's located. And this is the complete problem. But now you have to create the domain, which is a little more of a challenge, because now the domain will go from -infinity to the vertical asymptote, -infinity to the vertical asymptote, and then from the vertical asymptote to the hole in the graph at 5, and then after 5 to infinity. And this is the domain. Again, the domain, remember, the domain goes along the x-axis. It's from -infinity to the vertical asymptote, -3, and then, it stops there, and it picks up on the other side, but it doesn't go all the way out to infinity as the previous problem did. It stops at 0. And you got to put that, stops at 0, and then picks up again on the other side of that, and goes from there all the way out to infinity. And the range will go from -infinity going up this way, and to y equals 0, and then from 0 to 1/8. All right, so it's going from -infinity, and it stops at the horizontal asymptote, which happens to be y equals 0, and then picks up again on the other side. Doesn't go very far, because at 1/8 there's the hole, so it stops there, and then it picks up again on the other side and goes all the way up to infinity. This is the complete problem from beginning to end. And those are the two problems. And one of them will be on the test. I don't know which one yet. I still haven't decided. Let's go on to the third problem. So the third problem, which was in the homework, came from section 4.8, and it was a partial fraction decomposition. Okay, so here's the problem that I gave, and it is 8x plus 24 divided by x squared. There was no parentheses there. X squared plus 4x minus 12. The first step is to factor the denominator. Then to establish that this, when it started out, when you were combining two fractions, it looked like this. It looked like a number over one of the factors, and another number divided by the other factor. And the next step in this problem is to take this part of the problem I'm going to spread out a little bit here so I have room, because the next step to this problem is to get rid of all the denominators. Okay, so this is what two fractions have been added. And when we add the two fractions, this is what we wind up with. So the first step is to get rid of the denominators. So we're going to multiply by x plus 6 times x minus 2. X plus 6 times x minus 2. X plus 6 times x minus 2. Okay. Purposely going very, very slowly to allow this to sink in. The next step is to cancel out what we're, the LCD, LCM, and you get 8x plus 24. And this cancels out with that, leaving us with a times x minus 2 plus this cancels out with this, b times x plus 6. And I should have allowed a little more room, but this is what it looks like. And the object now is to figure out what a is equal to and what b is equal to. So this is the way it's done. We first want a to drop out, so we let x equal 2, because 2 minus 2 is equal to 0, and 0 times anything is equal to 0. So therefore, when we let x equal 0, the a will drop out and we could solve for b. So the next step is let x equal 2. So 8 times 2 plus 24 will equal a times 2 minus 2 plus b times 2 plus 6. And continue. 16 plus 24 is 40, is equal to, this becomes a times 0, which is exactly what we want to happen, plus 8b. So this will drop out, obviously. And here, rewriting it, because I like the variable on the left, this is what you wind up with. You divide by 8, and b is equal to 5. And I draw a line because we're finished with that part of the problem. So again, refreshing, what I did was to let x equal 2. And that gave us the 0 and caused the a to drop out, permitting us to figure out what b is equal. So we can now, you can now practically go back to the original fraction and put the 5 up there and put 5 over x minus 2, but we usually wait until the end. So the next step is to get the b to drop out, and therefore we let x equal -6, and that will cause the b to become 0. The b times the 0 will cause that to drop out, and we'll be able to solve for a. So 8 times -6 plus 24 is equal to a times -6 minus 2. And that's -48 plus 24 equals -8a. -8a, I almost wrote a b. And this becomes -24 equals -8a, divide by -8. This time I kept it like that. I didn't switch it around because I don't know. And this becomes 3 equals a. There it is. All right. That's pretty much what we're trying to do here, is find out what a and b are equal to. And now we go back to this. Now we could kind of put this in the answer. So in other words, 8x plus 24 divided by x squared plus 4x minus 12 is equal to 3 over x plus 6 plus 5 over x minus 2. And the check is really important because, you know, there was a student, and I don't remember who it was. Maybe the student can come forth and reveal themselves to us, who had it backwards. But after they did the check, they realized it didn't work out. So they then just switched the numerators, and then it worked out. Who was that person?
That was me, Professor.
That was
Rose.
you, Rose. Okay. That was great. That was, I mean, I didn't quite know how to handle it because you kind of label things wrong, but as long as it works out, it doesn't really matter. But anyway, 3 times x minus 2 plus 5 times x plus 6 equals 3x minus 6 plus 5x plus 30. And that gives us 8x. I'm not even looking at, you know, what this, I don't even know what this is. 8x plus 24. So when this hopefully equals this, that's your check. And it does indeed work. So when Rose did this problem, this didn't turn out to be equal to this. So she realized that the 3 and the 5 needed to be, she had the 5 here and the 3 there. I don't know. I don't know why that happened, but anyway, it doesn't matter because all you do is switch it, try it, and if it comes out the same, that's the problem. This will also be on the exam, obviously. So the 2 problems that were in the homework, 2 of the problems that were in the homework, and again, I haven't decided which one it'll be, 1 or 2, but those problems are worth a lot of points, these two problems, because they're obviously, if you look at the problem from beginning to end, there's a lot going on here. There's a lot to do. First, you have to know what to do, then you have to know how to do it, and then you have to, you know, go through the whole process. There's so many places you can make a mistake here. It's really incredible. So it's worth a lot of points for obvious reasons. And that is the homework review.